Alright, so today we're going to solve equations. One of the fundamental things of algebra is being able to solve an equation for a variable. Okay, I really don't like it when people read to me, so I'm going to give you just the opportunity to read this on your own and maybe hit pause if I don't give you enough time, and then we will discuss it. Okay, so we're going to be finding solutions. So I want to determine whether x equals 5 is a solution of 6x minus 17 equals 16. So the first thing that I want to do is I want to replace that x with 5 and see if it makes a true statement. So I've got 6. Now remember, that doesn't mean 65. That means 6 times 5 minus 17. And I'm going to put a question mark above that equal sign because I don't know. And I want to know if it equals 16. So what is 6 times 5? It's 30 minus 17. Still don't know if that equals 16 yet, but I'm going to check. 30 minus 17 is 13, and 13 does not equal 16. So I would say no or not a solution. Okay, for this problem, what I want you to notice is that there is a y on both sides of that equal sign. There's one right here, and there's one right here. We want to determine if y equals 2 is a solution. So that means you have to put 2 in both places. So let's see if 2 is a solution. So I've got 6 times 2 minus 4. Is that, I'm going to put a question mark there, is that equal to 5 times 2 minus 2? So 6 times 2 is 12. Again, I'm not sure yet, so I'm going to put the question mark there. 5 times 2 is 10. 12 minus 4 is 8. Is that equal to 8? Yes. So you would say yes, or it is a solution. Okay, for this problem right here, this is just another way to model equations. And what they're trying to show you here is that the envelope means we don't know what's inside of it. So the way you would model the left side with an equation is you would say, I'm going to call this x. X plus 4. This line right here stands for equals. And I've got 5 circles over here, so I would put a 5 over there. Now, because this line means equals, that means that the left side is balanced with the right side. So that means that this is the same as that, and this is the same as that, this is the same as that one, and this one is the same as that one. So what has to be in the envelope? Well, what has to be in the envelope is just this one little circle right there. So that is another way to model an equation. So if you were to solve this, what plus 4 equals 5? 1 plus 4 equals 5. So x is equal to 1. Okay, again, I'm going to give you just a couple of seconds to read through this. You might want to hit pause. Okay, so using the subtraction property of equality, that means that whatever I subtract from one side of the equal sign, I have to do the identical thing to the other side. So I always, whenever I'm solving an equation, I ask myself, what is happening to this variable? Well, what's happening to it is I'm adding 8. So how do I undo addition? What is the opposite or inverse of addition? The opposite or inverse is subtraction. So I need to subtract 8. But what I do to the left side of the equal sign, I have to keep it balanced and do the same thing to the right side. So if I subtract 8 on the left, I also have to subtract 8 on the right. So what is 8 and negative 8? Well, that creates 0. That's what we wanted. So what's left on the left-hand side? I've got just plain old x. And on the right side, 17 minus 8 is 9. So this right here is our solution, x equals 9. Now the beauty of solving equations is that you can check your work. So I'm going to take this 9 and I'm going to put it in for x in my original problem just to see if my answer is correct. I'm going to check. So I've got 9 plus 8 equals 17. I'm going to put a question mark there just like we did earlier whenever we were seeing if something was a solution. Now I'm going to go ahead and do that math. 9 plus 8 is 17. 17 does equal 17, so yes, I do know that 9 is the solution, and x equals 9. Okay, for this problem right here, we've got 100 is equal to y plus 74. Now, a lot of people really have a problem with that variable being only on the right-hand side of the equal sign. And so a lot of people will turn this around and write it like this. And that's not wrong. It's okay to do that. You don't have to though, but if it messes with your head too much, go ahead and flip that baby around, okay? So again, it doesn't really matter whether it's on the left or the right, but you look at what's happening to your variable. What's happening to y is I'm adding 74 to it. So in order to undo adding 74, I'm going to subtract 74 from both sides. So what is 100 minus 74? It's 26 equals y. Remember that 74 minus 74 created 0, so it went away. And so this is our answer, 26 equals y. And again, a lot of people have a problem with that y being on the right, so if you want to flip that around, that's okay too. Y equals 26. Now again, can you go back and check your answer to see that that is the solution? Absolutely. So we're going to take this 26, I'm going to put it in where I see y. So is 100 equal to, what is 26 plus 74? It is 100. So I do know that y equals 26 is the solution. Okay, again, you might want to hit pause and read through this and try to understand this, but I am going to explain it here in just a few minutes. Okay, so using the addition property of equality, we have to take a look and we have to see what's happening to our variable. What's happening to our variable is we are subtracting 5 from the x. So, how do you undo subtraction? The opposite or inverse of subtraction is addition. So I'm going to add 5 to both sides of that equal sign. And so whenever I add 5, this creates 0. So I've got x is equal to 8 plus 5 is 13. This is my solution. Now again, my recommendation is to always check your work. So I'm going to take this 13, I'm going to put it where I see x. What is 13 minus 5? It's 8. 8 equals 8, so I know that my answer is correct. X does equal 13. Okay, for this problem right here, I've got 27 is equal to a minus 16. The opposite of minus is addition, so I'm going to add 16 to both sides of the equal sign. So again, this on the right, a minus 16, and then I'm adding 16, that creates 0. 27 plus 16 is 43, and all I'm left with on the right-hand side is just plain old a. So 43 equals a is my solution. I can check my work by taking that 43 and putting it where I see a. So I've got 27 and 43 minus 16 is 27. So I do know that that is the correct answer. Okay, again, you might want to go ahead and hit pause here and read through this. And the key things that I want you to get off of this page is the places where you need equal signs are typically use these words. And so whenever we translate phrases, those are the typical words that you're going to see where you need to place an equal sign. So go ahead and hit pause and read through this, and then we'll go ahead and I'll show you some examples. Okay, for this problem right here, I'm going to translate the sentence into an algebraic equation. The sum of 6 and 9 is equal to 15. So all they want us to do is translate. We don't have to do anything else to it. So the sum, that means addition. 6 plus 9 is equal to, sometimes it's easier if you put a box around where you need to put the equal sign, is equal to 15. That's all this problem asked us to do. We didn't have to do anything else. Okay, now we're going to translate this sentence into an algebraic equation. The product of 8 and 7 is 56. Product means multiply, so there's several ways you could write this problem. You could write 8 times 7, although I really want you to get away from using x's for multiplication. Is means equals. This would not be counted wrong, but again, let's try to get away from that little x and maybe write it like this. You could do 8 and then a little dot. You could do 8 and then parentheses. Lots of ways that you can write this without using the little x. All of these ways are correct, but I do prefer these three over that one. Okay, notice on this one it says translate and solve. So we're going to translate it first, and then we're going to solve for x. So 3 more than x is equal to 47. More than means add, so 3 more than x is equal to 47. Now, a lot of people have a tough time with that variable not being first. I don't really care. This doesn't bother me that much, but if you don't like the way this looks, another way to write this problem is like this. That is still 3 more than x. So now to solve this, if I had this problem on a test or a quiz, this would be part of your credit right here, because that's this part, the translate part. Now you need to do the solve part. So we're going to subtract 3 from both sides, and you get that x is equal to 44. So there's the other part of your answer that I would grade. Okay, for this problem right here, we're going to translate and solve again. Difference means subtraction, and I didn't really mean to put a box around that, but difference means subtraction. Y and 14, that's what I want the difference of. Is, that's where I want the box because that's my equals, is 18. So I want the difference of y and 14. And a lot of people here try to give me an answer of 4, and that is simply not correct. 4 minus 14 is not 18. So what you really need to do is follow this problem through and don't get in too much of a hurry. So I want you to add 14 to both sides. So you get that y is equal to 32. That's your answer. Y is equal to 32. Whenever I grade this problem on a test, though, because I asked you to translate and solve, I would be looking for this step right here and your final answer.